Welcome back, students. Today in this session we are going to study chapter number 14, statistics. So let us first learn some of the important terms which we are going to use in this chapter. So starting with the word statistics. So statistics is a branch of mathematics which deals with the study of collecting data, collections of data, and organization, analysis, and presentation of that data. So statistics is the branch of mathematics that deals with collections of data, organization, and presentations of those collected data. Now let us try to understand what the term data means. So data are facts or figures which are numerical or otherwise collected with a definite purpose are called data. Data is the plural form of the Latin word datum. So data is actually uh, facts or figures which are numerical and which are collected with a definite purpose. For example, here you can see some of the given examples. Temperature of cities. So recording the temperature of a city is an example of the collection of data. So say suppose for a particular city we have recorded maximum and minimum temperature as 40 degrees Celsius and 10 degrees Celsius. Then those numbers which we collect with a definite purpose are called data. And for example, we have collected the age of a particular classroom, the age of the students of the particular classroom. So those collected numbers will be our data. Now moving on to the next term, what statistics is. Extraction of meaningful information is studied in a branch of mathematics called data. So the extraction of meaningful information from the collected data is studied under the branch called statistics. So the word statistics appears to have been derived from the Latin word status, meaning a political state. So this is about the types of data. So you will come across primary data and secondary data. Say, what are primary data? When the information was collected by the investigator himself or herself or himself with a definite objective in her or his mind, the data obtained is called primary data. And when the information was gathered from a source which are already had the information stored, the data obtained is called the secondary data. So let us take an example to understand what are primary data and the secondary data. So here in your book it is given as height of 20 students of your class. So we are going to collect the data of the height of 20 students of your class. So there are two different ways. So one is collected by the investigator himself, asking each and every student in the class what their height is, and the next way is of collecting the information which is already available in the school record. So in the first case where the information is collected by the investigator himself, asking each and every student, that data will be called the primary data. And in the second case where the information is gathered from the source available or which is already available in the school records is called the secondary data. So these are the term primary data and secondary data. Difference between primary data and secondary data. Now let us study the next term, which is raw data. By raw data we means the data which is not organized, which is collected in the first hand. That is the data which is given here. Say consider the marks obtained by 10 marks, for example, in a mathematics test is given below. 55, 36, 95, 73, 60. Such numbers are given. Such numbers which is not organized, such data which is not organized are called raw data. And if you arrange this data, say if you arrange this data like in ascending or descending order, you will see that this data is organized. Our next term is range. What is the range of the data? So when you organize the data in a particular way, for example, here we have arranged this data in either descending or ascending or descending order. Here in this case, the data is arranged in ascending order. Okay, ascending order. So if you see the difference of the highest and the lowest values in the data is called the range of the data. So the range in this case is 95 minus 25, that is 70. So the range of this particular data is 70. So how do we get the range of a particular data? There is the difference between the highest and the lowest values of the data. That difference is called the range of the given data. So the next term we are going to study is frequency. So to understand the word frequency, let us take this example. So here are the marks obtained by 30 students of class 9 out of 100 marks. So these are the marks obtained by 30 students of the students of the class 9. So let us take for instance 4 students got 70 marks. See, as you can see from this data, out of the 30 students, 4 students got 70 marks. So the frequency of 70 marks is 4. So by frequency we mean the number, according to this example, the number of students who have obtained a certain number of marks is called the frequency of those marks. So as you can see, the number of students who got 10 marks is only 1 student. So that 1 will be the frequency of 10 marks. And here, for example, 4 students got 70 marks. So 4 is the frequency of 70 marks. So frequency is a number which tells that how many times does a particular data appear in a given set of data. So frequency is a number which tells us how many times does a particular data appear in a given set of data. So for example, as you can see, the number 60, the number 60 also appears 4 times here, 1, 2, 3 and 4. So the frequency of 60 marks is 4. Now the marks obtained by those 30 students are grouped under these tables, as you can see, marks. So those students who got 10 marks is, the number of students is 1, and 20 marks, for 20 marks the number of students is 1. Likewise, that the number of students obtaining 92 marks is 3 students. So these are all the frequencies, for that particular mark here. So in 50 the frequency is 3. So in total 30 students. This particular table is called an ungrouped frequency distribution table, or simply a frequency distribution. Next we are going to study the terms class intervals, class intervals, class size or class width, and the lower class limit and the upper class limit. To understand these terms, we take an example. Say here given example is example number 3. So these are the data of 100 plants. Each were planted in 100 schools during 1 month. So after 1 month, the number of plants that survived were recorded as here.
So 100 plants are planted in 100 schools. So these are the data of those trees which survive after 1 month in those schools. So in particular school 95 plants survive, and in the second school 67 plants survive. Likewise, these are all the data collected from the 100 schools where how many plants are survive after 1 month. If you look at this collected data, it is not easy for you to study this data at a glance. So to make it easy, such a large data are grouped into favorable classes, and they are presented as given in this table 14.2. So for example, the number of plants survive. So these are grouped into 20, 29, 30, 39, 40, 49, and 50, 59. Say in the number of plants survive are grouped into this, and we use the tally mark, and the number of schools, that is the frequency of this group data, are given here. So such presentation of data is known as a group frequency distribution table. So here we make the given row data easy, and it is easy for us to study this data in this way. So presentation of this data in this form is called a group frequency distribution table. Here we choose a favorable class white. So let us try to understand those terms again. So the grouping of this is known as the class or class interval, and their size is called the class white, that is 10. From 20 to 29, the class white is 10, and the lower class limit is the least number of the class interval, that is here in this case example 20, 29, and the upper class limit is the greatest number in the class or class interval. So groupings, these particular groupings are called classes or class intervals, and their size is called the class size or class weight. In this case it is 10, and the least number is called the lower class limit, and the greatest number is called the upper class limit. For example, in the class interval 20, 29, 20 is the lower class limit and 29 is the upper class limit. And this particular way of presenting data by grouping into class or class interval is known as a group frequency distribution table. Next topic is graphical representation of data. So in different ways we can present a data graphically. So in this chapter we are going to study the graphical representation of data in the form of bar graphs, histogram of uniform white and of varying whites, and frequency polygon. Let us first study what a bar graph is. You have already studied about the bar graph in your lower classes. So a bar graph is the simplest and the most widely used graph in which the numerical data is presented by bars or rectangles of equal width. For example, in this example number 5, the given bar graph is of about 40 students which were asked about their month of their birth. So as you can see, in January 3 students were born, and in February 4 students were born. May, as you can see, 5 students were born in the month of May, and in the month of August 6 students were born. So this particular graphical presentation is called a bar graph. So bar graph is the graphical presentation of numerical data by bars of equal width. These are the bars and they are of equal width. So looking at this graphical presentation, you can easily understand what the given data is all about. So in the x-axis it is given as months of birth, and in y-axis it is given as number of students. So the maximum number of students were born in August and minimum number of students were born in June. Looking at by just looking at the height of the graph, you can easily find out the maximum and the minimum
of the given particular set of data. So this form of graphical presentation is known as bar graph. Let us study the next form of graphical presentation, that is that of a histogram. So a histogram is also a form of representation like the bar graph, but it is used for continuous class intervals. For example, as you can see in this table, the class are continuous, there is 30.5 and then 35.5. The next class starts from 35.5. Here the previous class of the upper limit and the next class of the lower limit coincide. That is, they are continuous. As you can see in this class interval, these are continuous class. So to present such a graphical representation, we use histogram. So it is also a representation or graphical representation like the bar graph, but it is used for continuous class. Or in other words, we can say a histogram is a graphical presentation of a frequency distribution in the form of rectangles, one after the other. So if you draw the bar graph, of this particular frequency distribution, you will get the bar graph as like this. So here you can see between the graphs there is no gaps. So in the earlier bar graph, you can see there are gaps between the rectangles or the bars. But in a histogram, as they are drawn based on the continuous class interval, there is no gap between the bars. Such graphical representations are called histogram. See, there are no gaps in between consecutive rectangles. The resultant graph appears like a solid figure. This is called a histogram, which is a graphical representation of a group frequency distribution with continuous classes. One important point about the graphical representation of a histogram is that, unlike a bar graph, the width of the bar plays a significant role in its construction. That is, this width of the bar represents a significant role in the construction. So as you can see, in fact, areas of the rectangles erected are proportional to the corresponding frequency. So the area of this particular bar is proportional to the frequency of the particular class. So to understand what does that statement mean, let us take an example of here. Here you are given a frequency distribution table in which there is the marks obtained by 90 students. So in the class interval 0 to 20, seven students obtain marks between 0 to 20, and 20 to 30, 10 students obtain 20 to 30 marks, between 20 to 30 marks. And as you can see, the class interval in this first class is, the class Y is 20, and in the second class, the class Y is 10. If you draw the histogram of this particular frequency distribution table, you will come up like this, where you can see the width of the class interval, the width of the bars is not proportional. The width is more than this bar, and also you can see the width of this bar is also more than the other bars. So this is not proportional to the frequency of the given data. So here it is mentioned that the graph is given as a misleading picture. As we have mentioned earlier, the areas of the rectangles are proportional to the frequency in a histogram. Earlier, this problem did not arise because the width of all the rectangles are equal. But here, since the width of the rectangles are varying, the histogram above does not give a correct picture. So, to make this modification, what we are going to do is, we are going to make the areas proportional to the frequency. So we are going to make a modification in the length of the rectangle so that the areas are again proportional to the frequency. So what are the steps we need to follow? That is, the first step will be to select a class interval with minimum class size. As you can see in the above example, the minimum class size is 10.
and the length of the rectangles are then modified to be proportional to the class size of the tens. For example, the first class that is from size 0 to class class 0 to 20. The class size is 20. So we are going to make it proportional to the length of the rectangles. So as you can see in the histogram, the white is from 0 to 20. The class size is 0 to 20, and the frequency or the height of the bar is 7. To make it proportional to this minimum class size, there is minimum class size of 10. What we are going to do is we are going to divide the length of the rectangle, that is 7, by the class size, and then multiplied by the minimum class size which we have selected, and which is 10. So this is equal to 3.5. Now we are going to reduce the length of the rectangle from 7 to 3.5, that is making it proportional to the class size 10. So when we convert this class size from 20 to 10, we are going to reduce the length of that particular rectangle by 3.5. We are going to reduce it to 3.5. So proceeding in the similar manner, the class size are modified, the length of the rectangle are modified here, as you can see. So in the last class also, the class size is, the class width is 30. So and the length of the rectangle is 8. So to make it proportional to the class size 10, we divide the length of the rectangle by the class width, that is 8 by 30 into, and the minimum class size 10, that will be equal to 2.67. So now based on this particular modification, we are again going to draw the histogram like this, representing the histogram like this. So the class interval from 0 to 20, the length of this particular class is reduced from 7 to 3.5, and this particular class size, that is from 70 to 100, the length of the rectangle is reduced to 2.67, from 8 to 2.67. So this particular area of this rectangle will be proportional to the rest of the bars. So this is the correct graphical presentation of a histogram where the class width are not equal. Next, we are going to study the graphical representation of data of another form, that is of frequency polygon. So what is frequency polygon? Let us try to understand. So if we draw the histogram of a frequency distribution table, and when the midpoints of the respective tops of the rectangles, the midpoints of the respective top of the rectangles are joined by line segment, then the figure so obtained is called the frequency polygon of that particular set of data. This is the graphical representation of frequency polygon. So frequency polygon is formed by joining the midpoints of the respective tops of the rectangle after drawing a histogram by line segments. Frequency polygon can also be drawn independently without drawing the histogram. For this, we require the midpoints of the class interval used in the data. These midpoints of the class interval are called class mark. So the midpoint of the class interval are called the class mark. To find the class mark, we find the sum of the upper limit and the lower limit, and then the sum is divided by 2. So upper limit plus lower limit divided by 2 gives us the class mark of that particular class interval. So after calculating the class interval of all the classes, we can easily draw the frequency polygon without drawing the histogram like this. So in this figure 14.8, we have only drawn the frequency polygon without drawing the histogram. So to draw this frequency polygon, first we find the class mark of this corresponding classes. So knowing this class mark, we can easily draw the frequency polygon without doing the histogram. Next important point is frequency polygons are used when the data is continuous and very large. It is very useful for comparing two different sets of data of the same nature. For example, comparing the performance of two different sections of the same class. Next topic is measures of central tendency. So under this heading, you are going to study the term mean, median, and mode. So the mean or average of a number of observations is the sum of the values of all the observations divided by the total number of observations. It is denoted by the symbol x bar. So the mean of a number of observations is given by, for n observation, is given by x bar equal to summation of xi as I varies from 1 to n divided by n. Next, the median is that value of the given number of observations is divided into exactly two parts. So to find the median of a given observation or of an ungrouped data, first we arrange the data into ascending order. Then when the number of observations n is odd, that is the number of observation is odd, then the median is given by n plus 1 by 2. So when the number of observation is odd, the median is the value of the n plus 1 by 2 of that observation. And when the number of observation is even, then there will be two values of median. There will be the n by 2 observation and n by 2 plus 1 observation. Next is the modes. So the mode is the value of the observation which occurs most frequently. There is an observation with the maximum frequency is called the mode. For example, as you can see in this particular set of data, after arranging it into ascending order, we can see that 9 occurs the most. Here 9 occurs 4 times, so the mode of this particular set of observation is 9.